How's it going, everyone? Andrew Robinson here, back at it with another Max MSP tutorial video. In this video, we are going to talk about the Beam.core Max package. I am absolutely so excited about this package because it makes working with lights and lighting systems in Max incredibly simple. Like, so simple, you could run a full-on light show in a arena music venue from a Max patch now. It's that easy. Like, I cannot stress how valuable this package is, especially to somebody like me, because in case you didn't know, my day job right now is I work as a lighting designer in a music venue. So the fact that I can use a Max patch now to run all the lights in my venue is mind-blowing. Like, you've always been able to work with lights, but it's never been this simple. And so I am so excited about that. So let's just jump right into it. First things first, if you haven't, you need to download the Beam.core Max package. You can do that by clicking on the cube icon on the left side toolbar. It says Package Manager when you hover over it. Once you click that, it's going to pull up the Package Manager window, which has all kinds of packages that you can download. I highly recommend looking at all of them, seeing which ones interest you. But Beam.core Max is the feature package right now, so it's right here at the top, which is super nice and easy for us to download. You're just going to click on that and click install. Mine says uninstall because I've already got it installed, but once you install it, reset Max, and you are set there, and you are able to then use any of the Beam objects in that package in Max. And there are quite a few that do really incredible things for working with lights. The other thing you do need to know is that the Beam.core Max package does require a license key to use professionally. I highly recommend buying the license key if you are interested in using this in a professional setting. Doing things like that really helps support the people who make these packages possible. So always, support our developers out here. Again, you do need to buy the license key to do this professionally, but you don't need to buy the license key to just start learning how Beam works. It's totally free to use otherwise. Once you have that squared out of the way, you bought your license key, what you want to do is on the toolbar, the main toolbar up here, you're going to click Extras, and there's all these extra options for all kinds of packages that are the default packages in Max, or possibly for other packages that you have downloaded from that package manager. And you'll see that Beam.core Max is now an option here. And there's a few different demo packages windows we can click on. Right now, what we want to click on is the overview one. And it brings up this nice window, which has a bunch of links and buttons that we can click onto to quickly jump to those things. If you have your license key, you can click on the license manager button, enter in that key, get authorized, and get ready to get going. There's also all of these links right here for learning about how lights work. What is DMX? What is ArtNet? If you don't know anything about lights at all, if I said the word DMX and you have no idea what I'm talking about, I definitely recommend reading up on these first before really getting into anything. It'll make your life so much easier once you understand the terminology that is used to talk about lighting and lighting fixtures. But if you know all that, and you're just ready to get started, there's all these links over here for the individual objects in the package and what they do, as well as some demo sets over here that you can click through to see how they work, and then also some notes on the big main objects, which we're about to get to as well. While we have the Beam.core Max overview window open up, and this list of objects here in front of us, the main object that is the core functioning of the Beam.core package, believe it or not, is this beam.core object. It is what communicates and outputs to the lights. It's basically like the out to the lights from this package, and it is the core of every Beam package or every Beam patch that you will ever build. Because you need it in your patch to communicate to the lights that you are plugged into. That being said, there are two other very valuable, useful objects that we need to talk about. That is the beam.patch editor, which will look like something like this when you first create it. And then we also have the beam.io editor, which will look something like this when you first create it. And again, that's beam.patch editor for this. Let's make it nice and large and bold, just so it's easier to read. And this is the IO editor. And the IO is input output, if that helps you remember it. And again, it'll look something like this when you first create it. In this first one, in our beam.patch editor window, we can input all the lights we have, what kind of lights they are, how many channels there are, as well as work with the tag system that is in the beam.core package setup. And this lets us communicate with specific channels. It's actually really cool how it works. But basically, yeah, the patch editor is the object you will use in your patch to add lights to the setup to communicate to, and basically get all the lights set up in the way that you want to work how you want. The beam.io editor edits our inputs and outputs. This is very important with how you are connecting to your lights. Right now, I have this object in real life called an NTEC DMX USB Pro. It is a USB to DMX converter. And you see down here, I have this USB device and it says NTEC DMX USB Pro. That is what is allowing my computer to communicate to my lights that I also have plugged in and set up on the floor right now. When you first create this beam.io editor object, it'll probably look something like this where it's blank. I just clicked on the clear button to clear it. And if you click on this plus button, you'll get this nice pop-up window. And in it, you'll see types, and you have your input type, which right now there's just the ArtNet input, which if you are needing to read data into DMX data into the computer, this is probably what you will need to do that. And then you have a few different options for output as well. You have ArtNet output, which is a pretty common form of converting from like the computer to DMX data. And ArtNet node output, also very common when you have very, very large lighting systems. And then USB output, which is, again, what I'm currently using. It's just a USB to DMX converter. And then this CITP visualizer is if you want to communicate to some kind of capture program. I think actually in the demo patches for the Beam fixed package, they are using a program called Capture, which is pretty nice. It looks really cool and it lets you actually see like the lights in the stage that you are building. So that is also super useful. For now, since I'm using a USB to DMX converter, we are going to use the USB output option. And then once you select that, it says device, select device. It automatically registers and recognizes the NTEC DMX USB Pro that I have plugged in. So perfect. I'm just going to click it and click add output and then select it. And it is there. I am now outputting through the USB device. And then with that set up, the next thing you need to think about is, the lights in your patch as well. You see here, it says generic dimmer pack, and there's two of them. That's because I have two lights plugged in. And I have some weird knockoff lights where the order of channels is intensity first, then red, then green, then blue. If we click on this plus button, we're going to get a similar pop-up window here in the patch editor. And if you see profile, you can click on that drop-down list. And there's all these lighting profiles that come with the package. If you are, a lighting designer, you may recognize some of these. And basically, the way this works is you have a profile fixture profile, which basically says, what the type of light is, what the channels are, what they do for that light specifically. This is how, even industry standard lighting consoles work. Like Grand MA is the industry standard for concert lighting consoles right now. And when you are creating a patch in Grand MA, it's the same concept. You put in fixture profile, the type of light it is, what the channels are. And because of that dictionary of the fixture profile, it knows that, like, yeah, this light has a lamp in it and you can turn that lamp on and off, or it's got a gobo wheel and it's like these 8 gobos you can choose from. All of that is internal to a specific light, and it all works based on the profile fixture. That being said, I have some knockoff lights that are super generic. They have 16 channels of data, even though I think half the channels actually don't do anything. They're really weird lights, to be honest, but they do a decent job for just at home messing around with things. And so we have a few different ways to work with some lights like this based on their genericness. And you see there's even all these options. There's, generic RGB, generic dimmer, dimmer pack, RGBI, RGBW, RGBW 16-bit. If you have just, generic lights and you know what the channels are, you can select the corresponding generic profile and be able to work with them. But like I mentioned, these are some weird off-brand lights where it's not RGBI or RGBW, it's IRGB, intensity, red, green, blue. And because of that, this generic RGBI profile picture doesn't work. This generic RGB one doesn't work. I have found that the only default profile that works with my lights the way they actually are meant to work is the generic dimmer pack. And that's because the generic dimmer pack just gives us 4 channels of dimmer profiles, which basically, every light, every channel, you can think of it sort of, I guess, as a dimmer, because each channel will have correspond to a specific value where it's like 0 to 255, and the red channel will, control how much red there is. That's just one dimmer channel. And like classic old school spotlight lights, work on just one dimmers because it's just the light bulb that you want to be able to control the intensity of. In that same way, that's sort of all we're doing here. We just have 4 generic dimmer channels that we want to be able to control the intensity of. I said there's 16, but the first 4 are really the only 4 in these lights that we need to work with. That is basically all we're going to do and all we really need to do. Once you have the correct profile for the lights that you have set up, there are these other options. You can choose to define how many there are in the setup window. I have 2, so I just set that to 2. Start universe. A universe is basically a grouping of lights. It goes up to the first 512 channels. So if your channel limit starts to exceed that, you need more universes, and thus something like a node, which lets you communicate out to multiple universes. But unless you're running lights in some sort of large arena, you will generally not have more than 1, maybe 2 universes, depending on how many lights you have and what kind of lights they are. But with some, generic 4-channel lights, it's going to take quite a lot of lights to get to universe 2. So we're not going to worry about that. And the start address is 1 because that is the first channel address that you can start on. The way the rest of them gets determined is based on math. If you have 2 lights and they're 4 channels each, then the first light would be on the first address, and that address value corresponds with the channel in the light. So address 1 on the first light will control whatever that first dimmer channel is, which in my case with my lights is intensity. So intensity is on that. Address 1 is the intensity channel on my first light. Address 2 would then be the red channel on that light, 3 the green, 4 the blue, and 5 the intensity of the next light. And so that's how you know what address to set the lights to, because it's the amount of channels added to your starting point. So if my lights were 16 channels, which they actually technically are, my first light would be on address 1, and my second light would be on 17 because you're adding 16 to that 1. So the next spot is 17. If I had a third light plugged in, You add 16 to it again, so it would be 33 as the starting point. Fourth light would be 49, so on and so forth. And it all depends, the address, everything, it all depends on, again, what kind of lights you have, how many channels there are. You just got to know your setup and how to set this up when it comes to stuff like that. I'm doing my best to kind of explain those, but that is really more on like how just lights in general work. So if you're interested in that, again, I just highly recommend reading through those like learning about DMX links that I mentioned at the beginning of the video. With all that technical stuff out of the way, the next and actual like most main important thing to pay attention to when setting this up and working with the Beam for Max package is this tag section right here. A tag is basically a parameter name you assign to a lighting profile or a specific channel on it to communicate with that channel and using the rest of the Beam for Max objects. So for right now, I'm just gonna say wash because these are wash lights. And I'm gonna click add fixtures. And so here we go. I've just added those same generic dimmer packs into our patch editor. And if I click on one, you'll see that there is the tag wash. Now our second light you see starts on address 5 because like I mentioned, it's the next starting channel after the 4 internal channels of the first light. But because the lights I'm using are specifically 16 channels, the starting address for this light is 17, not 5. So I'm going to click in here and change that to 17. And you see it updated there, it updated there. And now we can start adding more tags to our channels and lights to be able to work with them better. So we have the tag wash here if we want to generically chalk to any of these channels. But these channels control different aspects of the lighting fixture. So it's really nice to also have each one be their own tag. So this first spot, as I've mentioned, for my lights that I have at home, it's the intensity channel. So I'm going to click this plus button over here on the tag and add a tag of INT for intensity. So we've added the tag INT to this first one for intensity. Our second channel is our red channel, so we can do something like red or maybe just R. Third is our green, so we'll just do G. And then our fourth is our blue, we'll do B. And let's do the same thing over here. Let's add a INT, R, G, B. Cool. And now that that is set up, we have our tags to communicate to any individual channel. The way to communicate now to our Beam patch editors and our lights and everything is using the beam.output object. And it says when you, in the little blurb, when you start to create this object, it says sends beam signals to the beam.core object. Our beam.core object is internal to the patch editor and beam.io editor objects. These are actually B-patchers that are containing max patches that are creating this UI. And inside those max patches, there is a beam.core object that is communicating to the light. So even though I said, the beam.core object is the most essential object, you never really have to worry about it because it's built into these objects. And you're, I'm going to say probably 99% of the time, going to use these two objects in every single beam patch you make because you need them to set the patch up, set up your lighting patch as well. So you really don't need to worry about the beam.core object because it's built into these objects. And the beam.output, you can think of it as like a send and receive pair with that beam.core. Whatever we send to beam.output is going to, without a patch core, be sent into that beam.core object and output to our lights. And the way it works is just through the tag system as well. And so there's this object called beam.tag. And it routes parameters to the fixtures, specifically the fixtures with the tag name. So because we gave the tag INT to spot 1 on our light 1 and the spot 1 on our second light, anything we send to the beam.tag object will get sent to these values. And we can actually even see that using a third very valuable object called beam.monitor. And the beam.monitor basically lets us look at every single channel in our universe. So any values we send to the beam.tag object with the now int tag label will be sent to those channels with that same tag. And all it has to do is be patched into the beam.output object to communicate to that. That is how it gets sent to these fixture profile parameters. In the middle of me talking about that, I also realized for some reason that our tag int did not work when it was all lowercase. I'm not 100% sure why, but I just changed them to capital letters. So it's capital int now for the tag. That seems to be working fine. I'm going to change that over here in the object now. And the last thing we need to do before we send any data value over is we need to use prepend dim. The dim message communicates with the beam tag object. It is the header that says, send this value to that channel. So you just need it there in order to send the data. And the cool thing about the beam.tag and the beam.core system for Macs is that all the values it takes are normalized floating point values. So it's a range between 0 and 1, which normally DMX works between 0 and 255, but it's easier to think between 0 and 1. So I'm going to press F on my keyboard, create a float number box, patch that in to that prepend dim object. And then as I turn this up, you'll see now in our monitor that the value on that channel 1 and channel 17 are starting to increase. And again, that is because that is our two channels that now have the tag int. And so that will increase the intensity on those lights. I now am showing you the wonderful lights I have set up on my floor, and you'll notice that nothing is coming out of them quite yet because we haven't assigned any values to the red, green, or blue channels yet. We've only turned up the intensity, which will determine the brightness of those color values, but we're not going to actually see that until we send those channels some values as well. So we're just going to copy what we did up here 3 times, and we're just going to change the tag parameters to what we set up, which is RGB. We're going to patch those into the beam.output. And now as I change those values, you'll see the value increase on the monitor object, and in real life, you will start to see the colors change on these lights. So there's the first light turning on, but for whatever reason, that second channel actually didn't get any values. So something must have happened. Let's look at it. I think there's just a typo somewhere in the tag. All I did was delete it and retype in the R, and now it's working. And yeah, you'll see as I change those values, the red turns on in the lights as well. So let's look at that for the others now, and we'll change the green channel. And since I left some red in there, it goes from red to kind of yellow color. And then if we were to take that out, take some of the red out, you'll see, okay, we are getting a lot of green. In fact, let's take the green out and turn up the blue. And cool, we're getting blue lights. We could add red if we wanted, a purple or a pink color. And if we change the intensity value, you'll see, yeah, we're just turning the brightness up and down at that color. And you can see, different ways that you could build this up. Like we could easily just put a swatch object in here or something and unpack it so that appropriate color channel goes to the appropriate lighting color channel. And now we can just select the color with the swatch. Super easy, super straightforward, not hard to do at all. One last thing I want to mention is that with creating fit profiles, there's currently these are the default lighting fixtures that come with the package. You may have a light that is not in here, like I did in my case, and you might still want to work with that light, despite the fact that there is not a fixture profile in this list to choose from. I believe they are working on an object that will let you create fixture profiles for your own lights. It's just not ready yet. You can go to the website for Beam for Macs and I think email them and ask them for a fixture profile if you really need it. But if you need something quickly and you're scared to email them and ask for that, maybe you don't want to overload them with work or something, whatever your reasoning may be, but you still want to use this for your lights, you can sort of build up your own profile fixtures by just combining these generic profile dimmer and dimmer packs together to meet the needs of your light. For example, the generic dimmer pack fixture profile works with my lights because they're iRGB, and that's just for dimmers. But as I had mentioned, there are technically 16 channels in this. One of those channels is a strobe feature. What if I wanted to use that strobe feature on these lights? But because the generic dimmer pack is only the first 4 channels, I can't get to that strobe channel. You can actually, by combining these generic dimmer and dimmer pack options to be the channels that you need. If I create a generic dimmer and I put it on the correct channel, which I don't actually remember off the top of my head, I think it's 8. It might be 7. We're going to have to do a little bit of guessing and checking, but if we just say start address 8, if that is the strobe channel, then this will work right away. But we're going to put tag strobe in there, add that fixture. We now have this on 8. We're going to copy over another one of these and change the tag to strobe. And that is not the right starting address. So let's try a different value. Okay, yeah, that's 7. It is channel 7 on this. So now when I turn up the strobe value, the first light will start to strobe. And if we were to copy this over again, make another one, we could say generic dimmer. And so if it's on 7, if it's on channel 7, that's 6 channels after our starting channel. Our second starting channel is 17. So 17 plus 6 is 23. We can also call this strobe. And if my math is right, now when I turn that number value up, both lights should start to strobe. And the reason that didn't work is because I said universe 23, not address 23. So it thinks it's way out there. Let's try that again. There we go. Both lights are strobing now. Perfect. And so with that technique, you can actually build profiles for your lights, whatever they may be. And you can also assign the names to them so you don't forget. You can call this, strobe channel light 2 or something, whatever makes sense to you. It's weird that I can't edit the name of the cell, but that's okay. Something like that to help keep you organized. You can sort of build your own profile fixture just through conglomerating things and assigning them to the right channel. And that's all it takes. And it's that easy. It used to be much more complicated to work with lights in Max MSP. And now it's so simple. So thank you to the guys who created the Beam for Max package. I am very excited to continue using it. I hope you guys learned something from this video and are also equally excited. There are more objects that let you do fancier things, make stuff audio reactive, but this is basically all you need to know to get started working with lights and the most essential elements. I know this was pretty all over the place with some theory. It's just because, you know, talking about lights is a lot. There's a lot to wrap your head around when you're getting started. So again, if any of that was really confusing, go read those links that I mentioned at the beginning of the video. They will explain DMX much better than I probably did. Hopefully this example at least made how these objects work together to run lighting shows clearer, and I will see you all in the next one. Thanks so much for watching. Bye.